The overall goal of this experiment is to develop a reliable and easy method to investigate the dynamically changing state of ionogels and to obtain information about subtle changes of their conductive properties during heating and cooling.
This method can help answer key questions in the ionogels field, such as how the dynamics and conductive properties change when transitioning between liquid and gel states. The main advantage of this technique is that it can follow subtle changes of the conductive and thermal properties of a sample during the gelation process and distinguish between the phases.
Most laboratories have the equipment for a thermal scanning conductometry setup. At its core is the measurement chamber. Nitrogen gas flows into a gas dewar with a heater. The nitrogen passes through a gas mixer that is just below a sample in a polypropylene tube. The tube is attached to a conductometry sensor that is immersed in the sample. For an experiment, set up the apparatus under a fume hood. Surround the sample and sensor with thermal insulation. A sense of the complete setup is provided by this schematic. A liquid nitrogen tank provides gaseous nitrogen for a heating and cooling medium. The nitrogen passes through a sample cooler and its temperature is regulated by a variable temperature controller. In the experimental chamber, the conductometer measures the conductivity and the temperature in the middle of the sample. A computer records the conductivity, temperature, and time for each measurement. At this point, prepare the experiment sample.